So 8.2, we would focus on how to test a claim about the proportion. So this section, we will learn what is the complete procedure for the test about population proportion P. Again, population proportion, we use lowercase p. So we will introduce the p-value method. We will focus on the p-value method and the critical value method. We will talk a little bit about the confidence interval, maybe. And we know the claim in this test will be the proportion, or the percentage, or the relative frequency, probability, something like that. It's just the lowercase p. So we will talk about one method. Part 1, we will talk about if we use a normal approximation to a binomial distribution, then we could use this method. And another part, we will use the technology. So first, let's check how to conduct a formal hypothesis test about a claim. We know a hypothesis test is just a test about a statement, a claim, an assumption, something like that. This time, we talk about the claim is about a population proportion P. So this whole section, we will talk about this kind of hypothesis test. The claim is just about the population proportion P. So when we talk about the population proportion, we actually talking about the binomial distribution. And the first method we're going to learn here is based on the normal approximation method. So let's check notation first. N is always the number of trials or the sample size. So the lowercase p is the population proportion. Again, without hat, it's from the population. It's about the population. And that will be the value in your hypothesis. In your null hypothesis, in your alternative hypothesis, you will have p equals something. In your alternative, you will have p is greater than some number, is less than some number, or is not equal to some number. So p is the value we're going to use in our hypothesis. We have another p hat. If the p with hat, that will be the statistic, the estimator, right? So it's from the sample. We call it a sample proportion. How can we get to the sample proportion? We use x divided by the total number. So if we know the value of lowercase p, of course we can get the value of q by using 1 minus p. Similarly, if we know the value of p hat, we can get the value of q hat. So it's just the notations. Of course, if we're going to use normal approximation method, we need to check the requirements. So all of the samples should be simple random samples. This is always the requirement, right? The second requirement is just for binomial distribution. So if we're talking about the proportion, actually we are talking about the binomial distribution. So we need to check if the binomial distribution conditions are satisfied or not. So this is just a quick review. Fixed number trials, all the trials should be independent to each other. And we can only have two kind of results, success and failure, right? And the probability of a success, so that's the probability of success. We can say that's the lowercase p, right? The probability of successes remains the same for all trials. Of course, if we want to do the normal approximation, both in p and q should be greater than or equal to 5. If these two are qualified, then we are free to use normal approximation method. If all the requirements are satisfied, we will use this z. We will use this z to be our test statistic. So I prefer to put a star to tell me this z is not the critical value or something. The generalized z-score, it is just the test score, test statistic. This z has the name. This name is test statistic for this test. So we're going to use this formula. Of course, after we get our test statistic z, we could use this z to find the p-value. This is called the p-value method. We use p-value to get to the conclusion. This method is called the p-value method. And we will use p-value compared to our significance level, alpha, then make our conclusion. Remember, what's the rule? The p is low, then the none must go. So, which means if we get a p-value is less than our alpha value, then we will reject our none. So this is the rule for p-value method. We will also talk about the critical value method. So remember, after we get the test statistic z, the z with the star, okay, we will need to find the critical value z. So then we compare the absolute value for these two z's, we could make our conclusion. So we were talking about equivalent method. We focus on p-value method and critical value method. These two are always equivalent to each other. But the confidence interval method is not an equivalent method to the previous two methods. So we will say we use confidence interval to estimate. We use confidence interval to estimate, but use p-value method or critical value for testing. So again, because confidence interval for the proportion, we cannot use confidence interval for proportion to do the test because the confidence interval method is not equivalent to the other two methods, which means maybe I use p-value method, I get that conclusion, I will reject none. But if I use confidence interval, maybe I get the opposite result, I fail to reject. So which one should you choose? Always choose p-value method and the critical value method. Confidence interval just for estimating. Let's check the true delivery example. So here we have this claim. So most customers uncomfortable with drone delivery. So this is a claim about the proportion, most, because we have the keyword here, most. What is most? Most means more than half, right? More than half, then we can say it's majority or most. So the more than half, which means the proportion is more than half. So this is a claim about proportion. More than half of the people, of the customers, so the proportion is greater than half. So before we start the test, we need to check, right? To check the requirements. We can quickly go through that because in your exam or quiz, you don't have to check the requirements, okay? But in your real life, in your future work, maybe you need to check. So first, they are randomly selected. So the sample is simple random sample. Simple random sample. And we know second one is about the binomial. distribution. So the fixed number trials, of course, 1 on the 9 is a fixed number. And we only have two kind of result, comfortable or uncomfortable. So, right, we only have two binomials. And we know both NP and Q are greater than 5. So all of the requirements are satisfied. Of course, we can always use the technology to help us to get the test statistic and the p-value. So this page shows you if we use this calculator, we could get the test statistic. So this Z is the test statistic, and this P is called the p-value. This is the p-value we're going to use. Okay? These two are the most important values we need to focus on. Of course, in our class, we will not talk about how to use the technology. We're going to use the table, right? We're going to use the table, and we will use the procedure in 8.1. 8.1, we talk about the general procedure, right? So we will use that procedure to show us how to do the hypothesis test step by step. So I hope you still remember the question. Step 1, we need to find which is the statement or the assumption or the claim we're going to test, right? So in this case, we find that sentence is most customers are uncomfortable. So we will try to find the sentence most customers are uncomfortable. Then we try to use the symbolic form to express this sentence. So we translate most customer to be the more than half, more than 50%. The proportion is greater than half. So the symbolic form P is greater than half, 0.5. So we will use decimal in our hypothesis. Okay, in our none and in our alternative hypothesis. We will not use percentage or the fraction. Probably we just use the decimal. Sometimes maybe fraction. Okay. Then step 2. By the textbook, it said we need to find the opposite of the original claim. But to my in my opinion, I do not want to use this one to confuse you. I only want to tell you from step 1, you already have this one, right? P is greater than 0.5. So you only need to write down this one and ask yourself a question. This one must be one of your hypotheses. This is always true. This one must be one of your hypotheses. But the question is, this one is your non-hypothesis or the alternative hypothesis. I should put H sub 0 or H sub 1 for this hypothesis. If you still remember the rule, you will realize that's our alternative hypothesis because the sign in the middle is greater than some number, right? But for the non-hypothesis, the only possible sign is the equal sign. So I will use P is equal to 0.5 as our non-hypothesis. So by this time, I've already listed what's the non and what's the alternative. Again, first step, we're gonna use the symbolic form to express the original claim. So by this time, we have this P, proportion is greater than half, 0.5. And I'm pretty sure this is one of our hypotheses. So the only thing you need to figure out is this is our alternative or non-hypothesis. If your original claim with the equal sign in your expression, that will be our none. But this time we have the greater than sign. So if it's not equal sign, this automatically go to our alternative. If you know the alternative, you only need to change the sign in the middle to be an equal sign. So I keep P, keep 0.5, but replace the greater than sign with the equal sign. So that will be our non-hypothesis. So we can see by this step, we will get these two as our alternative and the non-hypothesis. So step 4, we need to set a significance level called alpha level, also called the type 1 error, right? But in your hypothesis testing, we will set this as significance level alpha. And if the question didn't specify which value you should use for the alpha, then we will pick the default value, 0.05 as our alpha value. So we will pick 0.05 for this question. Step 5. Because we know we are actually testing a claim about the proportion. So the p hat is relevant to the test, right? P hat is relevant to the p. We're gonna use talk about how to get to the test statistic first. Okay, how to get the test statistic by using the normal distribution as approximation. So you only need to know we're going to talk about p-value method first. No matter which method we're going to use, we use p-value method or critical value method. These two methods are equivalent to each other. So we use these two methods to do the hypothesis test. But no matter which one you're going to pick, you always need to get the test statistic first. You need to get the test statistic first. So I put the star here to tell myself it's the test statistic Z. So this is the formula. So again, let's check the formula. P hat, of course, we know it's from sample. So in this sample, we have 45 customer responded with not comfortable out of 1,009 customer. So the proportion from the sample is 545 divided by 1,009. So this is p hat. And just like I said, can we know what is the p? Can we know what is the p-value? This one is called the population proportion. How can we know this one? You should always remember you can find the p-value in our assumption, or I would say in our non-hypothesis. We go back to check. What is our non-hypothesis? P is equal to 0.5. P is equal to 0.5. So this is the value we're gonna use, right? It's always in your none. None set the assumption. Assume P is equal to 0.5. We're gonna use this value in our assumption in your none. Again, in your none, you can always find this value in your non-hypothesis. And the remaining part is easy because we already know the p-value, right? 0.5. We can find what's the q-value. 1 minus p. And the remaining part, we just need to use the calculator to get the value. Test statistic z. So after we have the test statistic z, we could use p-value method. So we use this Z, test the statistic Z, to get the corresponding p-value or probability. Okay, so this time we check the Z table to find the value 2.55. We check the left column for the first two digits 2.5, then check the top row for the last digit 0.05. Then we can locate the body of our table for the area, right? We will get this value directly from our table. But this time, what is this area? This area is cumulative to the left. You remember, the Z table can always give you the area cumulative from left. But do you realize what kind of test we have? It's one-tail test or two-tailed test? It's greater than, so we know the direction. It goes to the right side. So it's one-tail test and it's right-tailed test. We need to get the right tail p-value. But this 0.9946 is the area cumulative to the left. So here, 2.55. We know this is our test statistic Z, right? And we also know the area cumulative from left of this Z is 0.9946. But we are actually interested in the area of the right tail because we are doing the right tail test. So we should use total area minus the area to the left to get the area of our right tail. So this is called p-value. This is the p-value, not the 0.9946. This is just the area cumulative to the left. It's not the p-value for this question. So this is tells you how can we do this, right? We are focused on the right side area. So next step, because we are using p-value method, we're going to use p-value compared to the significance level alpha, then make our conclusion. Remember, what's the rule? If p-value is low, so is low, this is our alpha, right? Is low, is less than alpha. What's our conclusion? We reject. The p is low, none must go. So we say reject none. So that's our conclusion. Of course, last step we will try to use the non-technical form to express our conclusion. We will say if none is p is equal to 0.5 and we reject this one, then we will say there is sufficient evidence support the alternative. What's our alternative? We reject our none. What's our alternative? Majority of the customer are not comfortable. The proportion is greater than 50% or half. So next, the last step, we try to use the non-technical form to express our conclusion. But in my class or in your test or exam, we will focus on the technical conclusion. Okay, we will focus on the technical conclusion. So this is called the p-value method. We use the test statistic Z to check the Z table to find the correct p-value, then compare the p-value with the alpha value to make our conclusion. So that's called the p-value method. Another equivalent method, we call it a critical value method. By its name, this time we're going to use the critical value to make the conclusion. But we still need to, no matter which method I'm going to use, I always need our test statistic z, right? I will always need test statistic z. So we gonna find the critical value z. This time we will have another z. So how can we find this z? We're gonna use the alpha value. We're gonna use the alpha value. Remember, this test is one-tailed test, is right-tailed test. So we will find what is our test statistic z, and we know it's just one-tailed test. So the right tail, we're going to have the whole alpha for this critical value, z sub alpha. Because it's one tail, so we do not divide the alpha by 2. We know the right tail is alpha. So if this is 0.05, we know we cannot use 0.05 to check the table because it's the area to the right side. We will use the area to the left side, to find what is the critical value alpha. And if you check the body of your Z table, you will find two values are closest to 0.95 because we cannot find the exactly same number as 0.95. We will find 1.64, 1.65, because we will find very close value will be 0.9495 and 0.9505. These two values are closest to 0.95, so corresponding Z will be like 1.64, 1.65, or pick the middle way of these two Z's, we get 1.645. Okay, this one is the special critical value, Z sub 0.05. So if possible, I hope you could memorize this special critical value. So if you set the alpha value as 0.05 for any one-tailed test, again, 0.05 alpha and one-tailed test, so Z sub alpha will be 1.645. It's not necessary to check the table every time if you memorize this value. So after we get a test statistic Z, so this is the position. See, this one test statistic Z 2.55 is greater than the critical value C 1.6, so it's right to this critical value. We know this test statistic fall in the reject region. So the whole part of the green part will be the reject region because this is based on the critical value here. The critical value separates the whole curve, whole region into two parts. The green part will be the reject region. So if your test statistic fall in this green region, then we should reject, right? Or you can use my method. Just compare the absolute value of two Z's. So here, this is one-tailed test. So we have Z sub alpha. If your test statistic has the greater absolute value, we will reject. Okay? So if your test statistic has the smaller absolute value than the critical value, we fail to reject. So this rule is just the same rule as you check the reject region to find if your test statistic fall in the reject region. That's the same rule. So you can draw the curve to see what is the reject region, or you can just use my rule, compare the absolute value of two z scores. They always get the same conclusion. Okay, you can choose which one you feel comfortable. Okay, the step 7, we will get the same conclusion. We reject the none. We compare two z's. This time 2.55 has greater absolute value, so we should reject our none. Okay, reject our none. So we always get the same conclusion by using critical value method and the p-value method. So here we get the same conclusion. We reject none. Last step, we still need to translate our technical conclusion into non-technical conclusion. If we reject this one, we will conclude that there is sufficient evidence to support the claim. More than half customers are uncomfortable with drone delivery. So we talk about the p-value method and the critical value method. We can say a little bit about the confidence interval. So this time you will realize, hey, I set the alpha level to be the 0.05. Remember when we talk about the confidence level in chapter 7, we know the confidence level is equal to 1 minus alpha. But here we know the alpha level is 0.05, but the confidence level is 90%. How could that be? Let's check it. This time we are talking about the right tail, so it's one tail. We know the one tail is alpha, right? So similarly, confidence interval is always the region in the middle. Always have two tails. So the second tail also have alpha. That's why this time, in this case, for one-tailed test, the confidence level is 1 minus 2 alpha. So in our case, it's 1 minus 2 times 0.05. So we will get 90% for our confidence level. So I just want to make you comfortable. So here, alpha is 0.05, and the confidence level is not 1 minus alpha. It's 1 minus 2 alpha, because each tail we have alpha. Because we set the alpha just for the right tail. Let's see. We could construct the 90% confidence interval. So we already know how to construct the confidence interval for proportion. For proportion, we use point estimate plus minus margin of error. We have the formula. How can we get the margin of error, right? So we just use the same procedure to construct the confidence interval. We will get this one as our confidence interval. So for this result, we will find the whole confidence interval is above 0.5, right? The whole or entire region of the confidence interval, entire range are above 0.5, because the lower limit is already greater than 0.5. The entire range is above 0.5. Then we will say we are 90% confident. This one contains the true value, and the true value is more than 0.5, because the whole range is greater than 0.5. So this time we get the same conclusion as the previous two methods, the p-value method and the confidence interval method. But this is not always the case. Sometimes I use the p-value method or critical value method. I will say we will reject none, but after we construct the confidence interval, we will say we fail to reject none. So the conclusion is we just use the p-value method and the critical value method to do the hypothesis test. We just use confidence interval to estimate, okay? To estimate. Of course, we could use the technology to help us to do the test. So we will just skip this part. All right. We could use the technology to help us find the number of successes x. Number of successes x. So if we already know the p hat is equal to x divided by n, of course, we do a little bit of transformation, we will get this. We will use this formula to help us find the x value. Okay, we can use this formula. So let's check this question. Here in this example, we have this percentage. 29.2%. So this is our p hat. This is the proportion. And this is the sample because from this sample, right? So it's the p hat. We want to know what is the actual number of adults who have sleepwalked. So that means we already know p hat. And we also know the number of n. So how can we get x value? Remember here, x is just equal to n times p. So we here just use 29.2% times this sample size. Okay. We will get, and we just round up to next whole number to will get this one. We round up to get this. This is how to find the number of x successes. So let's check another example.